Hello everybody, and welcome back to question number 7 on the 2007 Euclid Math Contest. So this is going to be the last question that has any of the light bulbs in it. 7A has a light bulb, as we can see here, and 7B is written, and then the whole rest of the contest is written from this point on. Okay, so let's take a look at our final light bulb short answer question. 7A, determine all values of x for which... what have we got here? Square root x to the power of log of x base 10 is equal to 100. Okay. So that looks like a complicated equation, and it's meant to look like a complicated equation. Logarithms are often added to questions to sort of scare people off, when in fact they're not that difficult to deal with. One other thing I'm noting, the base 10 here, I could rewrite this 100 as a 10 to the 2, and now I'm starting to get things in base 10. But we want to determine the values of x. So that's going to be kind of hard, because x appears twice in our equations. So let's just copy down and see what we can see and manipulate. We'll probably have to take a logarithm at some point. So root x to the log base 10 of x is equal to 100. Okay. What can we do here? Well, I'd like to get everything on this side base 10 if I can, because then, you know, this is 10 to the 2, and then the exponent would just be equal to 2. So the problem is this x appears at both sides, and it's a square root x as well. I suppose we could rewrite square root as x to the 1/2. And, you know, that's going to be equal to 100. And then the half could come out. We could have a half. And we've got that going on there. What else could we do? So the problem is we got this x as this base here, and I can't even begin to approach the log that's in the exponent. Now, log base 10 of x, if we call that, I don't know, y, that means that 10 to the y is equal to x. So, I suppose I could replace x here with 10 to the y, and this with 1/2 y, equal to 100. And then I'd have 10 to the 1/2 y squared is equal to 100, which is 10 to the 2. And there we go. Now I've got my powers, they're going to have to be equal. So 1/2 y squared is equal to 2. Now we want x, not y, but you know, we could probably try and find values for y and then get x. So multiply by 2, we get y squared is 4. So y is going to be plus or minus 2. And then just based on our definition here, 10 to the y is equal to x, which is just a rearrangement of this statement. See, people are scared of logarithms, but any log statement has a corresponding exponent statement that you can work with. Okay? And people find exponents to be a lot easier to work with. So if you're having trouble with that, try and convert your log statements into exponents, which is what I did. So x can be equal to either 10 to the 2 or 10 to the minus 2. And I suppose we could plug that in and double check. Square root of 100 is 10. 10 to the 2 is, 100. And then square root of, so this guy here is 1 over 100. So square root of x would be 1 over 10 to the power of negative 2. So that would be 1 over 10 to the 2. So that would be 1 over 100, which, is 100. All right. So both of those answers work out. And we would expect 2 answers because we got a y squared there. All right, not bad, not bad. We just need our final answer, but if, we wanted to write a sentence or two explaining what we were doing, by definition of logarithm, let this be y, we can rearrange the equation, that sort of thing. Adding that in just adds clarity, and clarity is always a nice thing to add in. Alright, but that's 7a there. Now 7b. In the diagram, line segment FCG passes through vertex C of square ABCD. So this guy here is a square. With F lying on AB extended and G lying on AD extended. And you know what this immediately reminds me of? Because it's a square. This looks like X and Y axes. So maybe we'll want to introduce some coordinates or something. But what are we being asked for? Prove that 1 over AB is equal to 1 over AF plus 1 over AG. Okay. Well, let's copy this picture down in our diagram. Or let's copy this diagram down in our notebook, I should say. So there's our line. And we're told that this fella here is a square. Let's give the square side length S, I guess. We got A, B, C, D. F was down here, and G was up here. Alright. So we have a right angle. We want to show that AG, 1 over that, plus 1 over AF is 1 over S. We've got some other right angles here. Actually, since AD is extended to G, I suppose we have right angles here as well. Looks like these are going to be similar triangles, right? I'll call this theta. This here is going to be 90 minus theta. And then what angle has to go here to add up to 180? So we got 90, we've got another 90, and then subtract theta. This is going to have to be theta, and so this is going to be 90 minus theta again. So, what do we say? We see that triangle GDC is similar, not necessarily congruent, to triangle CBF. Make sure you get the order of the letters right. Now we already have named S down here, so I don't want to give a new name to AG, but how about we call this T here? So let S equal AB and let T equal DG. So AG is equal to S plus T. That's nice and true. So now we'd have 1 over S is equal to 1 over S plus T. And now the question is, what is BF? Well, we got an S down here, so by similarity, GD over DC is the same as CB over BF. But that's T over S is equal to S over, let's call this U. So UT is S squared. Or rather, U is equal to S squared over T. Okay, but then 1 over AB is 1 over S. Now I have everything just in terms of S and T. Actually, I can't guarantee. Let's not start this way. Let's start at the other end. So 1 over AG plus 1 over AF is 1 over S plus T plus 1 over S plus S squared over T. What to do here? I feel like this probably just works out to S, but how do I show that? Common denominator, I guess? first let's clean this up a little bit. Plus, we'll just multiply top and bottom by t, so st plus s squared. Ah, but that's 1 over s plus t over s plus t. So they both have the s plus t thing here. And then we just need to get the same denominator on the first fraction. So just multiply top and bottom by s. So it'll be s over s plus t over s plus t. And now we can combine the top. Now those cancel, and we get 1 over s, which is indeed 1 over ab. So we managed to show it. Yeah, that was actually kind of short. Didn't have to use the coordinate geometry thing that I thought, although you probably could have. You know, g is sort of your y-intercept, and you can get probably get a formula if you call this something like, so f would be a0, and you might call this c is ss. You'd get a relationship between a and b, and then you'd have 1 over a plus 1 over b is equal to 1 over s. I'm sure you could do that with a nice coordinate geometry, but managed to do it just with similar triangles, and that's not bad at all. Not bad at all. But that finishes off question number 7. So in the next video, we're going to be taking a look at question number 8. It's hopefully 8, 9, and 10 I find are some of the more challenging questions, so we'll put our thinking caps on for that one. Feel free to take a look at the paper and take a look at question 8 before I get there, but I will see you guys in the next video. Thank you so much for watching.